A while back, a very dear friend of mine came to me and said, there aren't that many great cooking games out there. I mean, sure, you can go online and you'll find a bunch, but most of them are pretty simplistic in terms of the types of physics that they include. And my friend in particular said, wouldn't it be cool if there was a cooking simulator that actually included the real physics that go on during the cooking process? After nearly 4 years of back and forth conversations and dreaming up different ways to implement exactly these ideas, I'm finally ready to share with you a playable version of the multi-physics cooking simulator. If you go to my GitHub page, navigate to the IMPART open source library, which stands for Interactive Multi-Physics Analysis in Real Time. There you'll find a link to a live demo to play an initial version of the steak cooking simulator through the web browser. Clicking on the demo, I start up the steak simulator, which from the outset looks pretty simplistic, but let me walk you through all the details. So, first of all, clearly we have this piece of meat that's jiggling around on this pan that's sitting on top of a stove. And the meat itself is actually modeled as an elastodynamic body undergoing large deformations. So I can bounce it around, it'll flip around, it'll jiggle, it'll do all kinds of interesting things. It'll, maintain contact with the pan and these kind of outer boundaries of this limited domain, and I can do all kinds of fun things. I can also play around with the meat by pressing the arrow keys to cause it to shrink or grow in different directions, kind of like a muscle stretching in some ways. So I can control it through the pan by clicking on the pan and moving the pan around, or I can kind of jiggle the meat around and cause it to stretch out and do all kinds of fun things. Now, that's not everything. Obviously, we want to cook this piece of meat. So to do that, we have to turn on the stove. You can press the plus button on your keyboard to introduce a heat source, which is modeled as basically a radiation source that will start generating heat, which through radiative heat transfer will start to heat up the pan. And once the pan gets hot enough, then the steak will start cooking. We can visualize what's actually happening in this cooking of the steak by representing color changes as the amount by which this steak is starting to cook. And I can look at that visually just in terms of the color changes, or I can also switch my color visualization scheme to an infrared spectrum to visualize temperatures by pressing the C button on my keyboard. And now you can see that I can actually visualize the temperature both in the pan and through conductive heat transfer between the pan and the steak. I can see that I'm starting to heat up my piece of steak. Very cool. So what's also interesting to note is that as this piece of meat starts to heat up, especially along this interface, it starts to get nice and brown, just like we would like with a nice, well brown exterior on a piece of steak. But you also notice it's kind of shrinking. It's almost like this edge of the steak is losing volume almost. And part of that is explained through the physical process of cooking. As you continue to cook this piece of meat, it starts to dehydrate. It starts to have a lot of the water inside of it want to boil off, and so you actually lose volume in the process. And those portions of differentially heated meat in this chunk of material will actually lead to differential shrinkage, which is kind of what you would see if you were to cook a steak in practice. So now there's some curvature built into this piece of meat, but it's getting a little toasty on this side. So let's go ahead and try to flip it over. Maybe we can kind of like play around with it and try to get a relatively even cook on this thing. But obviously there's a lot of things that you can do in this environment just as a sandbox, but also to hopefully improve your understanding of what's really going on in terms of the physical processes of cooking. It's definitely a much more complicated process even than what I'm doing currently. There's plenty of other types of physics I could build into this, which I'm currently not including. Things like the transport of water or hydration throughout the steak through some kind of mechanical process. I'm not currently considering those effects. Also, other types of loss of heat through the surroundings and other kinds of convective heat transfer. I'm not representing that either. But nonetheless, it's still a very cool initial implementation of this idea. I encourage you to go play around with it, find it online, try to get the perfect cook on your steaks, and maybe you'll learn something in the process. If you have suggestions on things you'd like to see or expanded features in this cooking simulator more generally, feel free suggest them in the chat, and I'll be happy to take your ideas into consideration. But yeah, go have fun.